Alrighty then. We're wrapping things up, coming to the crescendo. We'll take a little slightly different take on things today. I'm going to talk about Earth systems, but in a hierarchical sense. And I've spent my career thinking about how, well, not all my career, because this is part of it, a big chunk of my career thinking about how universities are organized and how we might better utilize that organization or the resources there to solve problems that matter. So very early on, Michael Crow and I came up with a diagram that looks like this, and I'm going to try and embed a much nicer version of it in the video, and we'll see how that goes. But basically, it says that we can think of the disciplines, or we can think about how to break down problems on Earth in the following way. There's a set of problems that are physics, that are physical. They have to do with the laws of F equals ma, quantum mechanics maybe. Well, yeah, definitely. But from how we live, force equals mass times acceleration, the laws of thermodynamics, Maxwell's equation, electrodynamics, the orbits of planets, all that kind of stuff. That's all in here. Then there's a set of disciplines that study life. And basically, well, it's the life sciences, it's biology, etc. Over here, you have math and physics, obviously physics, chemistry, that sort of thing. Here is biology and many of its sub-disciplines. But basically, it's life. It's biological processes, cells, human health, that sort of thing. And then we have a whole set of disciplines that are dominated by the fact that humans are a little different as a species than other species on Earth. And in particular, it's that we have a very strong and overwhelming sense of intentionality. That is, we can imagine a future and then work toward that future. And we can do that on a scale and with a magnitude that's different compared to the rest of the species on Earth. So we write stories, we tell stories, we imagine the future, we imagine the past. So in here are the disciplines of history, literature, economics is in here, those kinds of disciplines. And then you'll notice, at least in the better image of the diagram, so each of these is an ellipse, and the ellipses at first order, there's the intersection of two ellipses, and so this is blue, this is meant to be yellow. See, I labeled it yellow even though it's orange. And so in the CMYK color scheme, you get green in here. And so green, so there's a whole set of systems and things that we study that are at the intersection of physics and intentionality. In the broadest sense, here is engineering. We imagine that we want to build a tall building, and then we, using the laws of physics, the strengths of materials, we build a tall building. We imagine that we want to fly in an airplane. An airplane is a highly intentional object, but it's mostly physics and our desire to get places more quickly. So that's this little section here. Then there's a section over here which I've labeled orange, which in the CMYK system becomes orange. And here we have, I've put medicine because while our biology doesn't always work quite well, we have developed the ability to change that biology. And we do that because we want our bodies to work in different ways. And also, let's see, where am I going to put that? I suppose biomedical engineering, maybe not. Biomedical engineering might be in here. But certainly medical thinking about how our bodies work, and medicine, typical medicine is in here. Also in there is agriculture. Plants have grown. I mean, if you think about wheat, wheat started being harvested, I don't know, but it was grass. My guess is in the Fertile Crescent in the Tigris-Euphrates neck of the woods. And then we started realizing that we could plant these seeds, and then we started realizing that if different species of these seeds were interbred, that we got different seeds. So agriculture is firmly in that in the sense of humans need and want food, and in order to grow it, we need to understand life. And then finally, up here in this purple sector, the intersection between physics and life. So leaving out human intentionality for right now, and I'm going to come back to that. It would be ecology, the classical discipline of ecology. It would be an example of a way that humans think about the world, that universities are organized to think about the world, that is at the intersection of physics and life. So let's go around and add a kind of an example system for each of these. And some of you have studied these for your, or written about them for your midterm. But certainly, in terms of physics, a system that is physical is Earth's albedo. Sun shines on the Earth. Certain amounts of heat of that heat are absorbed. Certain are reflected back. And so, understanding how albedo affects how Earth works is basically a problem of physics. If we come from here, that is at the intersection of physics and intentionality, we have the ozone, the system that leads to the depletion of the ozone hole, but also we have greenhouse gas emissions. We learned, in the next video I'll talk about this a little bit, we learned to burn fossil fuels and to capture the energy from those to drive our economies. The burning and the chemical processes that do that are physics. That we do a lot of it is human intentionality. And one of our big challenges is to separate our economies from carbon. So carbon is in here. Understanding the carbon cycle is a classic problem here. Now let's put up here just carbon cycle as a system. There's stocks and flows of carbon as they go in and out of biological systems. Intentionality. So the classic in my career, I'm going to draw little squares around these to say that they're systems. The classic system in my career anyway that's purely intentional is public policy. How we make public policy, special interests, understanding when a problem is a problem, how we try to change those problems. So the system of public policy would go here in intentionality. Let's see, carrying on around to the intersection of life and intentionality. I hit on this earlier, human food supply. Human food supply. So supply chains are clearly intentional, but in order to make human food, be it vegan to hardcore carnivore, involves growing food. I mean, even if you're a hunter-gatherer, your food supply is going to be at the intersection of your desire to have food, or your understanding that famines and all that come and go, and so maybe you store food. Let's see, the life, the biology. Well, the one that's on everybody's mind right now is COVID-19. And here I'm not talking about the pandemic itself, but I'm talking about the effect of the virus on an individual human. That's a life issue right there. Let's see. All right, so that's around the middle now. But then I haven't talked about this part in the middle. And E is, let's dash across the board here, draw a line here, and say Earth systems. So, at the scale, we're going to understand how the Earth system, the planet as a whole with its boundaries, at some place up in the atmosphere where very little mass travels in and out, but a lot of energy goes back and forth. So a couple of examples of where physics, life, and intentionality all intersect. Well, the obvious one is climate change, at least in the context of our group here. And then, I guess, another truly spectacular one right now is a pandemic, the system that leads to a pandemic. And here, actually, I started as I was making my notes with the idea of public health. Public health is a problem that deals with air pollution, toxins, and that sort of thing. It deals with cancers and the effects of these cancers on the functioning of, in particular, human biological systems. And then, of course, it's humans who are trying to stay healthy. Let's see, John Snow was the guy. There was a cholera outbreak in London. I don't remember. It was in the 19th century. And nobody could really understand it, but this guy, John Snow, made a bunch of maps of where people were sick and realized that, where people were sick, they all tended to be getting their water from the same place. So he, it's maybe in the green, John Snow got public health officials to remove the pump handle so they couldn't pump water, but they took away the handle. An early example of public health as being at the intersection of all three of these. Now, that's a problem that was at the scale of London. Climate change is a problem that is at the scale of the planet as a whole, and of course, a pandemic is the same thing. We could say epidemic and think about Ebola, which has yet to. Whoa, damn, I'm sick in and out. Ebola hasn't ever risen to the, thank God, scale of a pandemic. So this is, in addition, our systems can be organized in hierarchies from the perspective of learning about them and being, understanding them from an academic, intellectual perspective. It can be useful to break things down like this, but ultimately we come back to the middle of the diagram and have to deal with all of the interconnections that are implied. All right, that's that one. Talk to you later.